Hello and welcome to a new problem solving session. And we have one more problem at hand. You can see the heading, that is a puck in a magnetic field. And the problem is puck is a small ball, nothing else. A small puck of mass m carrying a charge q lies on a plane inclined at an angle alpha. The coefficient of friction is mu, of course, between the incline and the puck, and there is a magnetic field B perpendicular to the plane. See in the figure, not below. The puck is released with zero initial velocity. Find the steady state velocity of the puck, including its direction. So the problem is this, and it is immediately obvious that if mu is greater than equal to tan alpha, mu is greater than equal to tan alpha, we have nothing to do here. The buck won't move at all. So we will examine the case when mu is less than tan alpha, because in that case puck will be moving. So how can we solve this problem? So first of all, there is nothing else, so we need to consider the forces acting on it, and I've drawn a picture for it showing all the forces acting on the puck, and which is here. You can see this picture, and let's consider the forces acting on the puck. And there are components of gravitational force acting on it. Gravitational force, of course, and it is named Fg, and Fg will be certainly equal to mg sine alpha. And the force of friction, that is Ff, and it will be directed opposite to the direction of puck's velocity. I have assumed in this direction, so the force is acting in this direction, and its value will be obviously mu mg cos alpha, mu mg cos alpha, and the magnetic force that will be directed perpendicular to the friction force and perpendicular to the velocity. You should consider the direction of the magnetic force by yourself, because I am not able to show you. So, but these are going to be perpendicular to each other, undoubtedly, because it's a magnetic force which is perpendicular to the velocity, and this magnetic force can be written as QVB, because V and B are perpendicular to each other. So for a steady state motion, I guess the vector sum of all three forces, that is Fg plus friction force plus magnetic force, their vector sum will be equal to 0. And taking into account that these two forces are perpendicular to each other, we can simply write here an equation like Fg square equals Ff square plus Fm square, and from here we can find the steady state velocity, and it's a simple question. You will get the value something like mg by qb under root sine square alpha minus mu square cos square alpha, get this value, and to find the direction, we can get the angle between velocity vector and fg, this vector. And this vector is nothing, you will get eventually that it will turn out as sine inverse mu by tan alpha. Get this problem, solve it yourself. Thank you very much for watching.